This video is about application of exponential functions. We will use a certain formula to solve a real-world problem. Formula for compound interest. This formula is given in the IB formula booklet. Compound interest. FV is the future value. PV is the present value. N is the number of years. K is the number of compounding periods per year. R% is the nominal annual rate of interest. When compound interest is calculated yearly or annually, this K equals 1. Half yearly, K equals 2. Quarterly, K equals 4. Monthly, K equals 12. For exponential growth, when you see the word increased or appreciated by R%, we will use A equals P times 1 plus R% to the tth power. Normally, this t is the time. A is the future value. P is the present value. For exponential decay, you will see the word decreased, reduced, depreciated by R%. Then we will use this formula. A equals P times 1 minus R% to the tth power. For exponential growth and exponential decay can be related to the geometric sequence. Common ratio is 1 plus R%, or it's 1 minus R%. Andrew, Tommy, and John have $5,000 in their saving account. Andrew considers investing the money for 5 years with a bank. The bank offers an annual interest rate of 3.2% compounded quarterly. Calculate the amount of money Andrew would have at the end of 5 years with the bank. Give your answer correct to 2 decimal places. In IB exam, financial problems, normally we have to correct the answer to 2 decimal places. We will use the compound interest formula. Future value equals present value times 1 plus R over 100 times K to the K times the nth power. Based on the given information, we do know future value is we are looking for, and present value is $5,000. Interest rate is 3.2 over 100. Compounded quarterly, K equals 4. In a year, there are 4 quarters. N is the number of years, so N equals 5. So we do the substitution. Future value equals $5,000 times 1 plus 3.2 over 100 times 4 to the power of 4 times 5. We will put this into your calculator. So we put these expressions into calculator to the power of 4 times 5. Enter. $5,863.82. B. The average rate of inflation per year over the 5 years was 2%. Hence, find the real value of Andrew's investment at the end of 5 years. The real interest rate equals given interest rate 3.2% minus 2%. So we get 1.2%. This is the real interest rate now. Then we still use the same formula, plug in future value equals $5,000 times 1 plus. This is the real interest is 1.2 over 100 times 4 to the power of 4 times 5. Go to calculator. Up, enter. We just need to change this 3.2 into 1.2, then enter. This is our answer. Let's go to C. Instead of investing the money, Andrew decides to buy a used car that costs $5,000. At the end of 5 years, the car will have a value of $900. It may be assumed that the depreciation rate per year is constant. Calculate the annual depreciation rate of the car. This is an exponential decay problem. The exponential decay formula is future value A equals present times 1 minus R% to the tth power. Based on the given information, A equals 900, P equals 5,000, T equals 5. So we are looking for this R. Now do the substitution. Let's go to equation solver. Control menu. Enter, enter, enter. R equals 29.0. So the depreciation rate is 29.0%. Tom wants to invest his $5,000 in an account such that his investment will increase to 1.5 times the initial amount in 5 years. Assume the account pays a nominal annual interest rate of R% compounded monthly. Determine the value of R. We will use this compound interest formula. Future value equals present value times 1 plus R over 100 times K to the power of K times N. From the given information, we do know future value equals 1.5 times $5,000. Present value equals $5,000. And K equals monthly means K equals 12 because there are 12 months in a year. N is the years equals 5. Then we do the substitution into this equation. 1.5 times 5,000 equals 5,000 times 1 plus R over 100 times 12 to the power of 12 times 5. Let's go to equation solver. We will type the equation into calculator first. Then we go to control menu. Enter, enter, enter. It didn't work. Then we go back over here. Enter. Just delete extra stuff. We only leave that equation. Control menu. Enter. Then this time we will put the lower and upper bound. Lower is 0. Upper bound, you know the interest rate, highest one could be 100%. So I will put the lower is 0, upper is 100. Then enter. They give you the answer. Let's go to next question. John wants to invest his $5,000 in a different account. Assume the account pays a nominal annual interest of 3.4% compounded annually. After M month, the amount of money in the fixed deposit account has appreciated to more than $8,000. Find the minimum value of M, where M is natural numbers, which means counting numbers. Based on the given information, $5,000 is the present value. 3.4% is the interest rate, 3.4 over 100. Future value is $8,000. Remember this N is the number of years. So you have to change this M month into years. So M over 12, this is the number of years. K equals 1. Then we plug all the values into this equation. $8,000 equals $5,000 times 1 plus 3.4 over 100 times 1 to the 1 times M over 12 power. $8,000 equals $5,000 times parentheses 1 plus control divide 3.4 over 100 times 1, we don't have to write, to the power of control divide divided by 12 as the power. Then control menu, enter. We got M equals 168.688. Read the question carefully. We want to figure out minimum value of M, and this M is a counting number. So we have to round up so that we can get this future value. It's more than $8,000. So M equals 169. This is the minimum value of this M.